Okay. Hi everyone, I'm Joe again. This is joint work with Jonghyun, Choi, Neumann, and Larry Davis. So the goal of this work is to learn motion representation for video action recognition. We want to do it without relying on handcrafted features as input, like using optical flow as input in two-stream networks. And we wanted to do it directly from raw pixels, RGB values. And we want to do it without pre-training on large-scale dataset, but leveraging the unlabeled data for self-supervised learning, for learning a motion representation. So we propose to use optical flow estimation as a surrogate task for learning video representation, motivated by FlowNet that is able to learn optical flow from raw pixels. So to compute optical flow in our network from videos, we extend the ResNet to a 3D ResNet for multi-frame input by replacing the 2D convolutions with 3D convolutions. Inspired by FlowNet, Yue-Net, and voxel-to-voxel network, we employed an encoder-decoder architecture, which takes n input frames and n-1 optical flow frames estimation. We also predict the nth optical flow frame, which is the future optical flow. We do this because it's easier to implement the network with the same input and output resolution. And it learns to extrapolate the future, by extrapolate the future, you need to understand the semantics in the video, rather than just matching between the input frames. Our proposed ActionFlowNet is based on an 18 layers 3D ResNet. We employed a multitask learning in our network by jointly estimating the optical flow and action recognition. The idea is to have the network to learn optical flow and learn the motion representation inside the network, and then use the motion information learned in the network to improve action recognition. During inference, only the classification branch is needed for action recognition, and the decoder for optical flow can be removed so that it can have the same inference speed as a single task, single stream CNN. So we conduct our experiment on the UCF101 dataset, which consists of 13,000 videos. We see that our ActionFlowNet improves our simple fine-tuning of FlowNet by 3% and significantly better than training from scratch. Shows that the motion representation is important for action recognition. When compared to the model trained with large dataset, which is an unfair comparison because we are training only with 13,000 labels, ActionFlowNet still outperforms the ImageNet pre-trained networks, and also outperforms the very popular C3D model without pre-training on large-scale dataset. It is only inferior to the model that is recently released with pre-training on the large kinetics dataset. When compared to previous work that also models on raw pixels and without pre-training on large-scale labeled dataset, our ActionFlowNet significantly outperforms the previous unsupervised representation learning work with a large margin by over 23% improvement to previous work. So to conclude, we proposed ActionFlowNet to learn motion representation for action recognition. It jointly learns the action recognition and optical flow directly from raw pixels. And it gives competitive performance to the networks pre-trained on large-scale dataset. We also have more analysis on the quality of learned optical flow for action recognition. So please check out our paper for more details. Thank you.